Hello people, in this video I'm going to present my new project. This project tackles Radiance Cascades. Radiance Cascades is a novel approach at global illumination. I present a 2D example for it. We can also switch to a standard global illumination approach. As you can see, there is not much of a difference between those two, apart from the quite visible artifacts on the edges. However, the performance hit that we suffer actually when switching to global illumination is so significant that I think we can look at the artifacts with, well, indulgence, let's say. This app also allows you to switch colors, switch width of the brush. We can see how nicely the colors interpolate. There is also capability to erase certain things. We have the eraser here, and what is cool about the eraser is that we can see how quickly the new color fills the space that was erased, and I really like it. I really like it. It's really nice to look at. This app also allows you to inspect the whole render pipeline behind this image, starting from the canvas. So this is the space where you actually draw something. You can think about it as MS Paint. Next, the painted pixels are assigned a value of the UV they are located at. Okay. Next, we are performing the jump flood algorithm over this image. Okay. The result of jump flood algorithm is that each pixel that was not filled previously is now filled with the value that corresponds to the UV of the closest pixel that was filled. Okay. In other words, each pixel is now assigned a UV value of the object closest, that is the closest to it. Okay. Next stage is SDF, which basically we calculate the distance between the UV value assigned to the pixel and its actual UV value. So for objects it will be 0 because objects were not filled during the jump flood algorithm. However, for a pixel that was filled during the jump flood algorithm phase, okay, this will create some value that is non-zero. Basically, it will give us the distance to the closest object. And the last stage is the render stage that just renders the image. It uses the SDF field, SDF texture, and the canvas texture. Now, what's really cool about this app is actually the architecture behind it. I don't think I've come up with anything that is groundbreaking. However, I'm really satisfied with it because it, as you can see, it works really well, and I fashioned it after quite prominent idea in rendering, which is render graph. If you look at Unity, Unreal Engine, or Blender, you will see that some shaders are using graphs that have nodes, and those nodes, they have inputs and outputs, right? That's exactly how I think about this render pipeline. Each stage is a single node that has inputs and outputs. A single output, to be very precise. Each node has a single output but can have multiple inputs. And each node can be an input to the different node, okay? So it allows us to do these chains of nodes. As you can see, there is a render node class. It has inputs vector, but it can also be bind as an output. Okay? I'm purposefully making a virtual method because I know that some of those nodes, it's not so easy to establish which of the render targets to pick. And yeah, actually, each of those nodes, they have render targets, and this, as you can see, it has not a render target. So starting from the simplest node, let's say a copy node has a single renderer target that might not be even present. And why is that? Actually, maybe it will be a good idea to filter the null pointer here, or maybe the constructor takes care of that. It probably does. So how it works is that the copy node, it has a single copy shader assigned to it. It's actually a shader type. Nobody has a shader assigned to it. Shaders are owned by the shader manager only. And pretty much, I don't think there's a single persistent reference created to a shader in the whole program. I think not. It wouldn't make that much of a sense, I think. But going back to the copy node, it can copy the pixels between one and the other render target. However, it can also transform the pixels. So SDF shader is done with this, the printing to screen is done with this shader, the UV color space is done with this node. So it's pretty lovely, I think. We have the GFA node, as you can see. GFA node, it has to render targets, and that's exactly why I wanted to avoid predefining the bind output function, because here we have to render targets, and we must pick which one we actually render, which one we bind as an output, right? Global illumination node and Radiance Cascades node, they're a little more intense, so I won't be explaining them now, but feel free to look at the code online. I think that my code is quite readable in contrast to most of the code that you can see online. I really think about readability when I write it. So when we look at the app one more time, actually, there is something I would like to show you. Let's draw something. Okay, look at the FPS count. FPS count right now is 78. Let's say it's 80. Okay, and then let's switch to global illumination. It's what? It's 37. So there is a huge performance hit. However, when we analyze Radiance Cascades performance distribution, we waste a lot of FPS count for Cascades 5. As you can see, rendering fifth cascade takes about 20 FPS, something like that, 20-25 FPS, and then rendering fourth cascade takes about 100. Holy crap, man, 100 FPS. That's a huge hit. Now, what I'm thinking about is that I could be caching, for example, the fourth cascade and rendering the fourth cascade only, let's say, 2 frames, or only once every 4 frames, let's say. And again, I would decrease the frequency of rendering fifth cascade as well. And this would probably increase the performance of the application as a whole. However, I presume it will also decrease the quality of the image. But looking at the static scene, I will never be able to understand how the quality of the image is impacted actually. So I will need some dynamic lighting, and by dynamic lighting I mean light that changes over time. I will introduce a couple new modes here. Right now we have pipeline modes, but I will actually introduce application modes. So first mode, right now this is this paint mode, but I will introduce also a fire mode that will be rendering fire simulation. And fire simulation, it's dynamic lighting because it's fire, because it's dynamic, right? So it will help us establish how actually the rendering quality is impacted by distribution of rendering across multiple frames. So that's my idea for improving this method, or maybe just exploring it. Okay, I think that's all I wanted to say. Please check out this app. It's released on GitHub. There is source code available. Check it out, read through it. If you have any questions, ask it in the comments. If you have some ideas what to include in this app, also leave the comment. I will appreciate it, because any idea is appreciated. And yeah, see you in the next video.